Hey, welcome back to Spring Into Math 5. This is Mr. Stein here again, and today we're talking about understanding line plots. Okay, so understanding line plots. So the first thing that we need to explore is data. So what is data? Data is information, usually numbers, connected with real-life situations. Now, if we're going to count how many people, for instance, came to an amusement park in one day, the number of people that we counted would be the data that we're referring to. So what does it mean when we organize data? So organizing data means organizing numbers taken from real-world information, real-world problems, real-world situations. For instance, if we use the example that we discussed before, the amusement park, we would be taking the counts of the number of people who visited the amusement park and writing them in a way that is easy to read, easy to interpret, easy to understand, because the idea is to make sense of it. So there are a lot of different ways to organize data so that it's easy for someone to read and organize and understand. Now, one of the ways is to make a line plot, which is kind of the essence of this lesson. So a line plot is a display method we can use to organize data. Now you guys have seen these before. It's just one of those things that you don't use that often, so it always kind of sounds new. But once you see it, I think it's going to jar your memory. You're going to remember that you've used line plots in the past. So a line plot shows how many times each number appears in the data set. Now that's kind of a complicated way of thinking about it. It's basically saying how many times a number shows up. So instead of putting the information into a table, however, we graph it on a number line. Now, line plots are especially useful when the data falls over a large range. Let's take a look at data and then we can make a line plot out of it. So this data represents the number of students in each class at a local community college. So you can see here I have all kinds of numbers spread from 30 to 41, and then certain numbers repeat. Like 31 it repeats 3 times, 33 repeats 4 times, 37 repeats twice. There's only one 38. There's 2 40s and 3 41s, so kind of keep that in mind. So now if we look at this data, we can make a couple of conclusions. So the first is that the range of students in each class is from 30 to 41. The second is that there aren't any classes of 32, 34, 35, 36, or 39 students in them. So building the line plot involves counting the number of students and then plotting the information on a number line. So we use x's to represent the number of classes that each number of students has in it. So let's look at a line plot to kind of understand what I'm talking about. All right, so you can see here my line plot. Like I said, the span was from 30 to 41, so you can see my number line starts at 30 and ends at 41. And you'll also notice that we didn't have a class of 32 students, for instance, but we still included it on the number line as we did 34, 35, 36, and 39. And this is really important. Each value within the range of numbers needs to be represented even if the value is 0. So keep that in mind. No matter, even if a number is skipped, you can't skip it. You have to leave it there on the number line. Okay, so let's use this number line to answer some questions. So the first one, how many classes have 31 students in them? So if you look right here at the number line, at 31, you can see that there are 3 classes that have 31 students in them. All right, let's look at another question. How many classes have 38 students in them? So then again, you can kind of look at the number line. You can see here's 38, and there's one class of 38. All right, another question is how many classes have 33 students in them? So again, you're just going to identify where 33 is on the number line and count the x's. It's a really simple way to organize data. And so you can see here that there are 4 classes that have 33 students in them. Okay, so how can we make a line plot when our data is unorganized? And truthfully, guys, most data that you're going to get is going to be unorganized. It's not going to come in perfect numerical order. So unorganized data is data that is not written in numerical order, like I just stated. Another way to think about it is that we have numbers that are all mixed up. So let's look at an example. So Jeff counted the number of ducks he saw swimming in the pond each morning on his way to school. All right, so here are your results. You can see that one morning was 6, 8, 12, 14, and so on. You can see all these numbers are all just mixed up. So Jeff's data is unorganized. It is not written in numerical order. So when we have unorganized data, the first thing that we need to do is organize it into numerical order. So it's pretty simple. So basically you're just rewriting it from least to greatest. So you're just going to write all the 6s, 7s, all the way up to 14. So again, you can see our spread is from 6 to 14. That's our range. Okay, so then the next step is to make a line plot. So you can see here I started at 6 and go all the way up to 14. And then I record an X for every time that data point is recorded. So there were, looks like 5 days when he spotted 6 ducks in the pond, 2 with 7, 4 days of 8, 2 times he saw 11, 3 times he saw 12, 13 and 14 were each once, and then you can see he never saw 9 ducks or 10 ducks in the pond. Okay, so there were between 6 and 14 ducks seen, so each number from 6 to 14 is represented like we talked about. And there weren't any days where 9 or 10 ducks were counted. But remember, we still have to represent those numbers, because then if I was organizing the data and trying to interpret it, if a question stated how many days were there with 9 ducks, the answer would be 0. So you want to make sure you include that number on the number line so that you could then answer a question that comes up. Okay, so that's going to do it for this lesson on line plots. See you next time, and we'll kind of build upon this skill.